Dear friends, f is Riemann integrable. This is new concept for you. But as of now, you understand that Riemann integrable means it is integrable. F of x plus 2n pi equal to fx because period of f is 2 pi. And this is true for all f. Actually it is plus or minus there, but you understand it. Now I start with capital I equal to minus pi to pi f of a plus x dx. Now I suppose a plus x equal to y, where a is any real constant that we have mentioned in the statement that you aware that. Therefore dx equal to dy, and therefore x equal to minus pi implies y equal to a minus pi and x equal to pi implies y equal to a plus pi. So this integration begins minus pi to plus pi. Now this is a minus pi to a plus pi because now we write it in the form of y, and therefore f of y d of y. At this juncture, I want to emphasize and I want to give one special idea to you. And the special idea is that in mathematics, and in particularly for definite integration, if I say 1 to 2 r dr, you know that what is it? R square by 2, 4 by 2, 1 by 2, so answer is 3 by 2. And if it is instead of r, if I write x square by 2, you will have the same answer. Not only that, if you write y, it is y square by 2, you have the same answer. Is it clicking to you something new? The clicking point is that if we change the variable all over, the value is remain unchanged. Clear? This is very important notion, very important idea for this topic or particularly for Fourier series. It is universally true. It is not only true in this one. It is true everywhere. But here we are using it so many times. Now we split this integration in 3 parts. I am writing it here again. How I split this in 3 parts? Therefore, now this is the next step after this one, is a minus pi to minus pi 2 pi and pi to a plus pi. A minus pi to a plus pi, 3 parts. I think you understand. Now I am writing the remaining part. F of y dy, f of y dy, f of y dy. Therefore, for simplicity, I write 3 parts, I1, I2 and I3. The first one I1, second one I2, third is I3. Therefore, I1 is a minus pi to minus pi f of y dy. Just I started from here and we are doing some guessing something and then find something. Suppose y equal to z minus 2 pi, and therefore dy equal to dz obviously, and if y equal to a minus pi implies z equal to a plus pi. Y is a minus pi, put this value here and therefore z is a plus pi, and y equal to minus pi and therefore z is pi. Clear? If it is minus pi, y is pi, z is pi. So this integration even becomes a plus pi 2 pi f of z minus 2 pi d of z. I1 is a plus pi 2 pi f of z minus 2 pi dy is dz. This is f of z dz. Why? The cause is that function is periodic with period 2 pi. Means they have the same value. Now we change z to y. As I said earlier, you understand that if we change the variable everywhere in the definite integration, the value will remain the same. Clear? And if I change the order of integration, it will be negative. Can you understand that this is minus I3? Yes, it is. I can see, you can. Then this I1 is minus I3. So we can cancel out I3 and therefore this is I2. What is I2? Minus pi to pi f of y dy. As I said earlier, if we change the variable everywhere, the value remains unchanged. That we wanted to prove in this theorem. In this result, we want to actually prove this. And we got it. Okay. In the fourth one, minus pi to pi sine nx dx equal to 0. You know that the integration is cos nx upon n, and that is minus pi to pi. Therefore, this is equal to 1 upon n minus 1 raised to n minus 1 raised to n, and therefore this is equal to 0. Good. Do you understand? See here. If n equal to 1, this is cos pi. What is value of cos pi? Minus 1. What is value of cos 2 pi? Plus 1 minus 1 square. What is value of cos 3 pi? Minus 1 minus 1 cube. Here. Likewise here. In this one, this is equal to sin nx upon n. Actually, minus sign is there because we integrate here by sin. But there is the value is 0, therefore it has no meaning. Minus pi to pi. 1 upon n. Therefore this is 0. Because any value of pi, sin pi sine 2 pi 3 pi whatever, that will be 0 because it is on the y coordinate, so y axis. This is equal to 1 by 2 minus pi 2 plus pi sine dx. And as you know that the value of sine is 0 everywhere as per 1, and therefore both these values are equal to 0, and therefore this is 0 because of this one. Now here in this one, apply cos plus cos formula. M and N are different, and as per this formula, both of these are 0 plus 0, and therefore this is okay. And one thing more there, here the case in which M and N are different. What happens when M and N are same? So I can add this value here. If N and N are same, then this is equal to minus pi to pi cos square nx dx. Okay? M and N are same. Now the case is N equal to N. So this is equal to 1 plus cos 2 nx, so it is equal to what it will become? The first term one by 2 minus pi to pi dx, and the second term minus pi to pi 1 by 2 minus pi to pi cos 2 nx dx. This value is 0 because of this. So we have to calculate only this part and therefore this is equal to 1 by 2 x minus pi to pi, and therefore this is pi plus pi, and therefore this value is pi. Clear? So instead of cos, if there is sine, we have sine. So if M and N are same, at that time we have it is sine square nx. At that time this is minus there. At that time this is minus there, and here it is cos 2 nx. But again by this formula this value is 0. So again we have 1 by 2 x minus pi to pi, and therefore again we have the same answer, it is pi. And this is 5a. This is 5b. Now, dear friends, here we start with definition of Fourier series. The Fourier series is actually approximation of function over closed interval minus pi to plus pi. This is approximation. An and Bn are defined like this. An equal to, so here first we understand fx is approximately equal to 1 by 2 a0 plus sigma n equal to 1 to infinitive an cos nx bn sin nx, where x is in minus pi to plus pi. An and bn, these are Fourier coefficients, and therefore an equal to 1 upon pi minus pi to pi fx cos nx dx for all n. Bn equal to 1 upon pi minus pi to pi fx sin nx dx for all n. This is just a definition. You have to write so many times to understand and familiar with this definition. Now at this juncture, we have two notions: odd function, even function. Do you have idea what is odd function? Just think over it. The odd function is a function, just I am writing it here. F of minus x is fx. This is even function. And f of minus x equal to minus fx. This is odd function. Do you have illustration? Fx equal to x square, this is even function. Fx equal to x cube, that is odd function. Fx equal to cos x is even function. Fx equal to sin x is odd function. And likewise, you can find so many other functions. Now, as we restrict ourselves in definite integration, and the property of definite integration is like that. If f is odd function, this is odd function, this is even function, means multiplication is odd function. Just I am pausing here for a few moments in that. Odd function, even function, multiplication, odd function. Think about here, odd function, multiplication, even function. So here fx is odd function, even function, multiplication, odd function. And due to that, value of an equal to 0 for all odd functions. And therefore there will be no calculation of an there. Therefore value of fx is approximately equal to sigma bn sin nx. Is it clear to you? Now even function, this is even function. Even function, odd function, this is odd function. So at that time, this is equal even function and therefore it will become double. This is even function at that because fx is odd function and therefore by properties of definite integration it is double. Minus pi to pi, instead of that we write it is double and from 0 to pi. Now in this even point, fx is even, this is even, multiplication even, it is double. Now it is 0 to pi. But at that time sigma bn 0 means bn 0. Why bn 0? Because even odd, integration is 0 by property. So this is just a definition of Fourier series. Get familiar with that. In the next lecture, I will be here with sums of Fourier series. Today we stop.